The Indian Stone Age covers the prehistoric timeline from the initial use of stone tools during the Paleolithic period to the emergence of agriculture, domestication, and pottery in the Neolithic period across modern-day India, Pakistan, Bangladesh, Nepal, Bhutan, and Sri Lanka. Similar to other regions globally, in South Asia, the categorization of the Stone Age into the Paleolithic, Mesolithic, and Neolithic epochs does not have exact chronological limits. Rather, it outlines general stages of technological and cultural progress based on the tools and artifacts discovered at different archaeological locations. The Paleolithic, Old Stone Age period in India started approximately 2.6 million years ago, as indicated by the earliest identified locations of hominin activity, specifically in the Siwalik Hills of northwestern India. The term hominin is present here, leading to the question of what most accurately defines a hominin. In straightforward terms, a hominin includes species considered human, directly ancestral to modern humans, or closely related to them. The Mesolithic, Middle Stone Age, is characterized as a transitional stage occurring after the conclusion of the last glacial period, starting approximately 1000 BCE. The Neolithic period, New Stone Age, beginning around 7000 BCE, is linked to the rise of agriculture and other indicators of settled living or sedentism, in contrast to hunter-gatherer ways of life. The oldest Neolithic sites in India comprise Mehrgarh, located in modern-day Pakistan, which dates back to 6500 BCE, and Koldihwa in present-day Uttar Pradesh, India, where domesticated rice has been radiocarbon dated to approximately 7000-6000 BCE. Paleolithic era. The Paleolithic period in South Asia is traditionally divided into three phases: the Lower, Middle, and Upper Paleolithic. This era falls within the broader Pleistocene epoch, which lasted from about 2.58 million years ago to 11,700 years ago. The terms Early Pleistocene and Middle Pleistocene are often used interchangeably when discussing the different stages of the Paleolithic period. Lower Paleolithic. The Lower Paleolithic period in South Asia marks the earliest evidence of hominid activity in the region and corresponds with the Early Pleistocene. This phase, which spans from around 2.6 million years ago to roughly 300,000 years ago, is characterized by the development of stone tools, notably the Acheulean industry. These tools are generally attributed to early hominids like Homo erectus. Additionally, the Soanian industry, named after the Soan River, a tributary of the Indus, is another key cultural marker of this period. Other prehistoric stone tool assemblages, known as Pre-Acheulean, also appeared during this time. Siwalik Hills, Pre-Acheulean. The Masol site, located in the Siwalik frontal range north of Chandigarh, India, was surveyed between 2009 and 2011 by an Indo-French research team led by Professor Yves Coppens of the Collège de France and the Academy of Sciences. The site yielded over 1,469 fossils from a stratigraphic layer dated to 2.6 million years ago through paleomagnetic dating. Among these, 45 fossils displayed green fractures, 12 had carnivore marks, and 3 showed cut marks. These cut marks were found on bones from large herbivores, including a bovid shaft and a rib from a stegodon, an extinct elephant-like animal. While some critics have attributed similar bone markings to large predators or natural trampling, the researchers concluded that these markings had anthropic origin, meaning they were made by humans or human ancestors. This conclusion was based on several factors, including the fact that the marks closely resembled those made by quartzite tools in experimental studies. Moreover, taphonomic analysis, the study of fossilization processes, did not suggest that the bones were scattered by a natural disaster, nor was there evidence of animal predation on these large animals. Taphonomy. Taphonomy refers to the study of the processes that occur during fossilization, such as decay, preservation, and the conditions that lead to the formation of fossils. The discovery of anthropic cut marks on fossilized bones in the Himalayan foothills places South Asia closer to the heart of hominin evolution than previously believed. These findings suggest that the region may have witnessed early forms of scavenging behavior, akin to what has been observed at other ancient sites, such as Dikika, Ethiopia, dating to around 3.4 million years ago, and Lomekwi, Kenya, about 3.2 million years ago. These sites predate Africa's earliest known hominin activities and extend the geographic and temporal boundaries of hominin evolution. Pothahar Plateau, Pre-Acheulean. While the Masol site provides direct evidence of quartzite cut marks, other sites in the region reveal stone tools that could have produced such marks. One of the earliest of these is the Rewat site, located on the Pothohar Plateau, which contains pre-Acheulean stone tools dating back to around 2.5 million years ago. Similarly, the Pabi Hills in northern Pakistan have yielded stone tools dated between 2.2 and 0.9 million years ago. The tools discovered at these sites, including both light and heavy-duty implements, such as simple end choppers, represent a distinct lithic technology that predates the Acheulean and Sowanian traditions. Earliest Acheulean sites. The Atarampakam site, situated near Chennai, was first identified in the 1860s by British geologist Robert Bruce Foote. It has produced some of the oldest known Acheulean tools not only in South Asia, but globally, indicating that hominins in the Indian subcontinent were already using bifacial tools, including hand axes and cleavers, approximately 1.5 million years ago. This dating has been confirmed through both paleomagnetic and burial dating methods. The half-life of aluminum-26 is half that of beryllium-10, meaning the ratio of aluminum to beryllium decreases over time, allowing scientists to date the burial event. These tools, dating to the same period as those found in Africa and Central Asia, challenge the conventional understanding of Acheulean migration and suggest that these advanced stone tool technologies either spread earlier than thought or developed independently across different continents. Isampur, located in Karnataka, India, is one of over 200 lower Paleolithic Acheulean sites found in the Hunasagi and Baichbal valleys, dating to around 1.27 million years ago. Although even older assemblages have been discovered at sites like Atarampakam and Bori in Maharashtra, which date to about 1.4 million years ago, Isampur is notable as a quarry site. Over 15,000 artifacts have been uncovered here, providing valuable insights into early hominin tool-making practices. The site reveals the entire process of lithic manufacturing, from selecting limestone slabs and removing large flakes to shaping tools into bifaces, like hand axes and cleavers through secondary flaking techniques. Acheulean assemblages and Homo erectus in South Asia. The presence of Homo erectus in South Asia is primarily inferred through the discovery of Acheulean lithic assemblages, which fall within the temporal range of this species. This association between Acheulean tools and Homo erectus is well documented at various global sites, including those in other parts of Asia. Acheulean tools have been found across a broad geographical range in South Asia, including locations such as the Kortalayar Valley in Tamil Nadu, the Hunsgi-Baichbal valleys in Karnataka, e.g. Isampur, Chirki-Navasa in Maharashtra, Didwana in Rajasthan, and Bhimbetka's rock shelters and nearby open-air sites in the Vindhya Hills of Madhya Pradesh. These widespread discoveries suggest that Acheulean technology was not confined to a specific region, but was utilized by early hominins, including Homo erectus, across the Indian subcontinent, indicating that these hominins had a broad geographic distribution. Middle Paleolithic period. The Middle Paleolithic period in South Asia is characterized by the emergence of flake-based technologies, which imply more advanced planning and possibly early forms of symbolic behavior. These innovations may be associated with early anatomically modern humans. At the prehistoric site of Atarampakam in South India, stone tools dating to this period provide some of the earliest evidence of the Levallois technique outside of Africa. This technique, originally found in prehistoric Europe and Africa, involves the preparation of a core, shaped like an inverted tortoise shell, to strike off large flakes. Atarampakam has played a significant role in our understanding of the Middle Paleolithic transition in South Asia. The open-air site has preserved not only the earliest Acheulean assemblages in the region, but also the earliest Middle Paleolithic tools, which are dated to around 385,000 years ago. This site has provided over 7,000 artifacts showing evidence of the Levallois technique, which were detailed in a 2018 publication in Nature led by Shanti Papu. These findings challenge traditional assumptions about the out-of-Africa migration theory, as Levallois tools were previously associated with Neanderthals and early Homo sapiens. The Atarampakam tools, however, date back to 385,000 years ago, making them some of the oldest known examples of this technology outside of Africa. This date is close to the 400,000-year-old Levallois point found in East Africa's Kapthuran Formation, suggesting that these tools predate the previous assumption that modern humans migrated out of Africa around 130,000 years ago. The broader implications of these findings remain debated. Shanti Papu, the lead author of the 2018 study, has refrained from attributing the tools to any specific hominin species, but speculates that they may indicate an earlier arrival of Homo sapiens in India, which would support a more complex, non-linear migration pattern out of Africa. Paleoanthropologist John Hawkes, who was not involved in the study, pointed out that the Atirampakam evidence challenges the view that modern humans spread from Africa due to superior technology. Independent reviewer Michael Petraglia described the discovery as a marvelous contribution to understanding human history in South Asia, filling a knowledge gap between 400,000 and 175,000 years ago. Petraglia suggested that these tools could represent independent technological advancements by early humans in South Asia, rather than a direct transfer of technologies from Europe or Africa. Instead of simply tracing technologies from Europe to Africa to South Asia, this could be seen as an independent invention by large-brained early humans. The question of whether the Levallois tools at Atirampakam were made by early Homo sapiens in India long before the widely accepted migration out of Africa, or by earlier hominins like Homo heidelbergensis, remains unresolved due to the absence of DNA or fossil evidence. Narmada Valley. The Narmada Valley in central India has yielded evidence of two distinct hominin populations during the Middle to Late Pleistocene period, approximately 250,000 to 70,000 years ago. Fossils discovered by anthropologist Anek Sankyan include robust yet unusually short clavicles, indicating the presence of a previously unknown, short stocky hominin that coexisted with a larger-bodied hominin, referred to as the Acheulean man. Early hominins of the Deccan Plateau. Further inland, on the Deccan Plateau in present-day Andhra Pradesh, the Jwalapuram and Kurnool caves provide valuable insights into the adaptability and cognitive capabilities of early hominins in South India. At Jwalapuram, artifacts have been found both beneath and above volcanic ash layers from the Toba supereruption, which occurred around 74,000 years ago in Indonesia, marking one of the largest volcanic events in the last 2 million years. The presence of Middle Paleolithic tools in both layers suggests that hominins survived this massive environmental event and continued to inhabit the area, demonstrating cultural continuity and resilience. This ability to adapt to extreme climatic stress points to sophisticated survival strategies. An analysis of these tool assemblages reveals similarities to Middle Paleolithic technologies from Africa rather than those found in the Levant. This has led researchers to propose that Homo sapiens might have been responsible for creating these artifacts. The timing of these discoveries aligns with genetic estimates for early human migration out of Africa, supporting the idea that modern humans could have been present in southern India around this time. Homo sapiens. Mitochondrial DNA analysis suggests that Homo sapiens entered the Indian subcontinent between 75,000 and 50,000 years ago. Cave sites in Sri Lanka have also yielded non-mitochondrial evidence of Homo sapiens in South Asia, dating to about 34,000 years ago. Microlithic assemblages discovered at Mahadabera and Kanha in West Bengal, India, have been dated to between 42,000 and 25,000 years ago using optically stimulated luminescence, indicating that microlithic technology and Homo sapiens presence in South Asia occurred earlier than previously documented. Radiocarbon dating of artifacts from Belan in southern Uttar Pradesh places them around 18,000 to 17,000 years ago. Let us briefly explain what is mitochondrial DNA and how it related to human migration. Mitochondrial DNA provides insights into prehistoric human migrations by allowing researchers to trace maternal lineages across generations. Since mtDNA is inherited exclusively from mothers, variations in mtDNA can reveal patterns of movement and population changes over time. In the Bhimbetka rock shelters in Madhya Pradesh, central India, cave paintings dating to approximately 30,000 BCE have been discovered. Additionally, small cup-like depressions in the Auditorium rock shelter date back to nearly 100,000 years ago. Fossilized vertebrates and Paleolithic tools have also been found in the Sivalix and Potwar region, Pakistan. Chert jasper and quartzite were commonly used by humans during this period. Neolithic period. In northern India, the Aceramic Neolithic, also known as the early food-producing era, lasted from about 7,000 to 5,500 BCE, followed by the Ceramic Neolithic period, which continued until around 3,300 BCE and transitioned into the early Harappan, Chalcolithic to early Bronze Age phase. Among the earliest Neolithic sites are Lahoradawa in the Middle Ganges region and Jusi near the confluence of the Ganges and Yamuna rivers, both dating to around the 7th millennium BCE. Recently, the site of Birana in Haryana, located along the ancient Saraswati river system, has been discovered, with Neolithic levels dating to around 7600 BCE. In South India, The Neolithic began around 3000 BCE and lasted until approximately 1000 BCE. The South Indian Neolithic is marked by the presence of ash mounds, particularly in the Andhra Karnataka region from 2500 BCE, later expanding into Tamil Nadu. Excavations at Adichanallur in the Thirunelveli district and other sites in northern India provide evidence of the southward migration of the megalithic culture. The earliest clear evidence of megalithic urn burials dates to around 1000 BCE and has been discovered in various parts of Tamil Nadu, particularly at Adichanallur, where archaeologists from the Archaeological Survey of India uncovered 12 urns containing human remains, charred rice grains, and Neolithic celts. These findings confirm the presence of the Neolithic period around 2800 years ago. Further excavations at Adichanallur are planned to continue uncovering new insights into this important period of South Asian history.